While you already may be aware of the feats of our next expert on board, but like a good host should do, I would still take a few minutes to describe a few lines about her. She holds the highly coveted IBM Distinguished Engineer title and is the Chief Architect for driving the DevOps for enterprise system strategy. This includes working across IBM to provide support in all platforms in a DevOps culture and removing any barriers to the transformation from a technology standpoint. In addition, she assists clients in the DevOps transformation, focusing mainly on the enterprise clients with C operating system. She's also a member of the IBM Academy of Technology and the Academy leadership team. In her more than 30 years in IBM alone, she has worked in many areas in development, test, services, and sales and distribution. And now she's going to light up your screens with her deep insights on DevSecOps and a system of record. Without much further ado, please help me welcome on the East stage the one and only Ms. Rosalind Radcliffe.
Hello, and I'm Rosalind Radcliffe. Welcome to this next year's DevOps India Summit 2020, this time virtually. So unfortunately, I can't be with you, but I'm happy to be with you virtually over this recording. This year, I want to talk to you about DevSecOps and how it applies to the system of record. So my normal discussion about where the mainframe fits in this world, but really bringing in that full story of DevSecOps and making sure that we include security as part of the process and practices. When we think about DevSecOps, when we think about processes and practices, one of the most important things is to remember it doesn't matter what kind of system you're building, whether or not it's the system of record, or it's that front-end mobile device, or it's that watch that you're building for. It doesn't matter. All the processes, practices, and culture can be the same. And this is the important part. When we think about DevOps or DevSecOps or any of those kinds of terms, we need to remember that that system of record doesn't have to be different. The culture, the practices, they can be the same. They can be equivalent. And we need to think this way. We need to think about not the system of record of being different, but it should be the same. How can we do the same kinds of things? And yes, there are a few things that are a little different, but if we start with the premise that it can be the same, then we get to the right point. At the core of most of this capability is a pipeline, and we need the pipeline in order to do the automation, in order to provide that ability to move quickly through the system. We need that automation capability, and the pipeline helps with that. And when we look at this pipeline picture, it's another rendition of the version of the pipeline that I like, because it adds in those inner loops. It adds in that fast feedback to really indicate what's really happening in this process. We want to do our coding. We want to build. We want to get that feedback. A build process with just a compile is going to give us a little bit of information, but we need to add to that process those unit tests. We need to add that security scanning. We need to understand whether or not we're following the code rules. All of those early test feedback, we want to get back to the developer as quickly as possible before we ever move on into the deploy process and then the testing process. And so when we look at this pipeline and we think about security, we want to think about security from that very beginning, from that initial code and build phase, and make sure this flows appropriately. In this picture, I've added a whole bunch of products, and it doesn't say you need all these products. It just says there are a set of products in each one of these capabilities that we want to deal with. And if you look at the chart carefully, you'll notice a bunch of open source products, because there's a lot of open source that people use in this space. And it's important to recognize that open source plays a big part in this world. When we look at the SEMs that most people are using, that would be a flavor of Git, GitHub, GitLab, one of those in the environment. And so we want to make sure that it doesn't matter which one you're using, it fits into the pipeline and how it fits in the pipeline. You'll notice in this environment, I've got SonarQube to make sure I'm getting that fast code rule feedback and understanding. You'll see AppScan to make sure that I'm getting that security feedback in this process. And what we want to make sure is that as we bring our systems of record into this process, we look at each one of these phases and figure out what's the right answer. What do I need to do? How do I need to do this? And then move through each one of the phases to make sure that if there is anything unique, for example, COBOL, I'm probably not doing COBOL in many other platforms other than the mainframe. And maybe I'm doing it for ZOS, maybe I'm doing it for IBMI, but it's not usually other places. And so when we think about COBOL, we need a COBOL editor. And so we do have to think about that, or PL1 or assembler or whatever language you're using. If you're doing Java, you want a Java IDE. So we need to pick the right IDE. We need to pick the right build process. And if I'm doing COBOL or PL1 or assembler, I need a dependency understanding that understands those languages. So under dependency-based build gives me that kind of capability. If I want to do unit testing, I need something, JUnit, ZUnit, XUnit, NUnit, whatever, the right unit testing. And then we keep going through the process. But let's start at that beginning, because that beginning really is a critical piece of this to make sure that as a developer, you really do understand and have the capabilities that you need. And when we think about the development practices, in this initial development phase, we really want the users to be able to do this fast flow and get that fast feedback. And whether or not that's being run on Z hardware, or whether or not that's being run in a cloud environment, say in an OpenShift environment running a Z sandbox, I can get that experience. I can get that fast feedback. I can understand what's going on. And then it can flow into the team level, it can flow in and then be deployed into the appropriate environments and fully tested and then deployed into production. This process that everyone goes through, whether or not it's distributed development or Z development, it can be consistent. When we look at this very first part, we want to think about what's the right developer experience. What's the right interaction that the developer should have? And it really should be a bring your own IDE thought process. What's the right thing for your developers? What's the right thing for you as a developer? Do you prefer Eclipse? Do you prefer VS Code? Do you want to use Eclipse Che? Well, it doesn't matter. You pick any one you want. With the capabilities available, you can go out to the marketplace and pull down the open editor, which gives you COBOL PL1 assembler. You can go out in VS Code and you can get the AppScan plugin to get security scanning. You can use Eclipse environment with a full IBM developer for Z. So you've got these choices as an IDE, and it's up to you as a developer or up to you as an organization to allow your developers these choices. And yes, you see Eclipse Che there. There's no reason you couldn't decide to provide a Che environment. Why not? And in today's world, when we think about the security concerns and developers working from where now? Their home or wherever they can get proper internet, Maybe the idea of a container-based development environment with the containers running in your secure environment might not be a bad choice. This gives you additional security and additional control over that source code rather than having it cloned all the way out to their laptops. But that's a choice. It's a security choice, it's a choice. What kind of experience do you want for the developers? What kind of experience do you want as a developer? What kind of experience is there for you to do what you want to do when you're building your system of record? And when we look at those IDEs, there are things such as code rules, understanding, and looking at it from a security standpoint or from just a general code rule standpoint. Now, it's really important. I say static code analysis and IDEs, and I'm talking about security and security scanning for Cobalt. There's one thing that's really important to recognize. Security by design applies to Cobalt the same way it applies to any other language. And a lot of that security training out there talks about things in terms of scripting or websites. But those same descriptions need to be thought about when we're building Cobalt. When we think about Cobalt, PL1, whatever language we're building in, developers still need to think about the way they write their code. Are you allowing a SQL injection? Are you checking things right? Are you doing the right thing in your coding? Yes, the system of record or the mainframe is a secure platform, and there's lots of security built into the system itself, pervasive encryption, all sorts of things. But that doesn't mean you as a developer can relinquish all rights to paying attention. So security by design applies everywhere. Now, some of the rules that we think about, I think, well, we've always just kind of done in Z. If we think about things like accept or other things, you know, we just have done them forever. So maybe there aren't those same security vulnerabilities just because of the practices that we've done. And maybe when you scan your code, you're not going to find security vulnerabilities. That could be because your developers who've been around a long time just followed good programming practices and had the systems built in. But you never know. It's important to watch. It's important to pay attention. Now, security scanning is just the first piece of this. We need to make sure that as we're moving through this system, we're treating ZOS or the system of record in the same way. We're thinking about it in the same way as we're doing the rest of our cloud native development experience. Are you providing the right experience for the developers? Are you providing that self-service environment so that they can get that experience? Are you doing infrastructure as code to move into this environment to allow full automation in the pipeline? And containerization, that's really important when we're thinking about our pipelines, when we're thinking about our capabilities. Why not apply those to the system of record as well? Spin up that environment for the developer in the Che environment using Red Hat Code Ready workspaces, or spin up a sandbox in that environment. So spin up their own ZOS environment. The next phase we have to think about when we're thinking about this security is automated testing. And you may say security, that's security scanning, etc. What's that got to do with testing? Well, it's got a lot to do with testing. The better that we understand how our code works, the better that we are ensuring that we don't have those basic problems, the more secure our system is. We don't want it ab-ending because of an improper function. Causing an ab-end can cause a problem with user experience. So it is a security problem. We want to think about making sure we're doing all the right testing. And that testing starts at the unit level, making sure we're actually doing our unit testing. And in that build phase, we can use capability to do that testing. And after we do our Z unit, we do our code quality scanning. So we're going to do our security scanning, our code rule scanning to make sure that that code meets standards. Now I'm going to give you a small caveat in that. You've got a lot of code running today. You've got millions of lines of COBOL running in the world today. Just because that old code does not meet today's code rules does not mean you need to go fix it. Maybe. If it has a security vulnerability, then absolutely you want to work on fixing it. But if you think about it, that code works. So we're not focusing on necessarily fixing that old code. What we're working on is the new code, the new and changed lines that are coming into the environment. We want to make sure we're testing that to make sure we're not introducing new problems. And over time, we want to add enough unit testing on that old code base as well to be confident that everything's there and working correctly going forward. But we don't have to go back and just build a bunch of unit tests on code that's been running successfully for the last 20 or 30 years. So we want to think about this in a correct perspective. But then there's this next phase of testing. And this next phase of testing is transaction level testing. And this is a little unusual. One of the things that we found is it's really hard in the ZOS environment to get that first level of integration testing. I really want that fast feedback. I don't want to have to deploy the application into an environment to get that feedback. The developer really should be able to get that fast feedback. And so we've done a set of work working in the core of ZOS to make sure we know how to capture the information, to provide a record and playback feature for this virtual test capability. It's called IBM WASI Virtual Test Platform. What it does is it really allows you to shift your application integration testing left all the way into the build process. I really can do that record of a transaction in my test environment. And then as a developer, I can play that back anytime I want to. I don't have to deploy the application. I can play it back. So I get that fast feedback into the system. I understand if the code change that I make affects the rest of the programs in that flow, and I can get that fast feedback. If I change a copybook that isn't going to have an effect on anything else, I can actually recompile those programs and I can get that fast feedback. I can understand that that COBOL copybook that I changed really doesn't affect anything else. Same is true for PL1 includes or assembler macros. Any one of those languages, and if your application is built with a set of languages, COBOL, PL1, assembler in the back, doesn't matter. You can virtualize that environment out. And you're literally virtualizing out the KICS environment, the TB2 environment. So you're running it as part of the build process rather than later stage. And if you need to debug it, well, you can run your debugger against the virtual task platform because it's not using a debugger. It's literally sitting at the exit level of the system, making sure that your programs can run without the middleware. And it stubs out every single call to the middleware so that all of those exec kicks calls don't go to kicks anymore. They literally are stubbed out. You get that fast feedback. Once you get past that build process and you have that fast feedback, and you really do know that your code works the way you intended it to, then you move on to later stage testing. That doesn't mean a later stage testing in time or a phase later. It means later in the pipeline. Let that pipeline flow. Get that next stage of feedback. Make sure you're doing the function testing, performance testing, full integration testing. This early stage testing shifts testing left, but it doesn't remove the need for that later stage testing. It just gives you that fast feedback. It lets you find defects sooner that are code related to allow you to focus on the performance of the system, to allow you to focus on that larger scale kind of end-to-end testing that you're still going to need, but maybe you do a lot less of because you found these problems sooner. One of the other things that's absolutely critical is test data. And test data falls into the security scope for a lot of reasons. The first one is production data has a lot of security concerns around it. You shouldn't be using production data outside of production in general. Now, I know you can use test data management tools and obfuscate and mask data, but you really want to think about where even that obfuscated and masked data should end up. And you also want to think about the fact that production data is fundamentally good data. Yes, it's good data. It got into the system. It doesn't have all those errors and all the problems. When you're doing early testing, you want to use fabricated data. You don't want production data. You want fabricated data because you want all those error situations that aren't in the system because the data couldn't get in. You want that totally bad data. You want some good data, but you want totally bad data as well. And you don't need thousands of records for unit testing. You need a small amount of data to run through the scenarios. And so that early testing, you want to focus on fabricated data. And maybe late stage testing, you want to use production data that's been masked and obfuscated for performance and scalability testing, because those are places where you do need lots of data. And you're not focusing on validating the response, you're focusing on validating that the system runs. And that's a very different kind of testing. When I want to focus on automated testing to validate the results, to make sure the code works as expected, I want smaller amounts of data and I want known data. And that's why it's really important as part of this testing process to have a test data management strategy, to have your golden test data in the appropriate places and deployed into the environment and running the tests. This really helps you in the environment, helps you control access to your data, helps you with your security. When we think about this, if we don't have that production data in the early stage environment, we have fewer things to worry about. We think about breaches and we think about people getting into systems and getting access to the data. We have to control the places where production data exists, even masked, obfuscated production data, because in many cases, there are ways to go back and figure out enough about the data. So we want to be careful and we want to ensure that we're securing our data appropriately as part of this process. And when we think about that pipeline, and we think about this testing and we think about this process of going through the pipeline, if we have everything going through the pipeline and we're pushing the code and the infrastructure changes through this pipeline, then we can reduce the number of people that have access to systems, again, helping security. We think about the production environment. Everyone's going through the process of limiting who has access to production, making sure that if you have production access, write access to production, that user ID is highly controlled. Well, if you've got a pipeline and the only way to make changes into that production system is through the set of pipelines, then you don't need people to have write access to production in the same way. You need fewer of those requests to go get into the system. Now, it doesn't alleviate the need for someone to go look at a problem. Problems will occur. Code is never perfect. We're trying to get it better. We're trying to do enough testing to reduce the risk, to be confident in what we're doing. We're doing enough security to ensure we're not letting things through that we know are problems. But they're always going to be problems. Therefore, we want to make sure we've planned for that. We have ways to get into the production system to see what's going on. But avoid making changes outside the pipeline, and then you don't need the same kind of elevated authority in production. All of this ties together to make sure we're securing our systems appropriately and building our pipeline with security in mind, and building our development practices with security in mind. Now, we've got some examples of customers who've gone through the story, but there's one on here I want to pull out. It's a large insurance company, and their system of record, their mainframe applications were in a sense done second. Their distributed teams were starting down the DevOps path, and they had pipelines. They hadn't done a lot of standardization, but they had pipelines. They were doing DevOps in a sense. They were moving, they were improving, they were doing a set of things. And the mainframe team came along after that had already started. And so when they built up their pipeline, they built up a scripted pipeline. They built what they called Day 2 DevOps. They learned from the experiences that had gone before and built their pipeline. And so when a security requirement came down, all code needed to be scanned, and there were a set of requirements, they could simply add that into their existing pipelines. And so for the first time, the system of record actually implemented this change for DevSecOps before everyone else could, because they had done Day 2 DevOps. They were ahead now, and they could implement the security scanning that was required. It's an example of this process. It doesn't matter what kind of system you are. Front end, back end, what matters is that you have this automated pipeline in place, that you're looking for continuous improvement, that you're looking for this journey of continuously evolving, moving forward, removing that waste, addressing those issues. These are all stories of customers who had different transition requirements. They were in different places to start out with and wanted to move forward with different processes, but they've all chosen steps to take, and they all continue their journey. They all continue their improvement process by making steps forward with each incremental improvement. Now, when we think about the system of record, it's no different. When we think about DevSecOps, it's all about this bringing everyone together, whether or not you're development, operations, security, everyone is playing a role. And we really need to make sure we've got business and IT working together as part of this process in order to deliver this business value. I talk a lot about pipelines and tools to help you be efficient, but DevOps, DevSecOps, BizDev, SecInfOps, doesn't matter what you call it. It's not a tool. You can bring in a bunch of tools and still not be improving your processes. So it's all about the culture behind the way you work. And it's making sure that you're really breaking down those barriers, breaking down those walls. And it's an additional wall. It's not mainframe and distributed or system of engagement and system of record. Everyone needs to be working together for this process. Everyone plays a part. Systems work together. People need to work together to deliver the value. So hopefully this session has been helpful. I want to thank you for spending the time with me, and I hope you have a wonderful event.